Hello everyone. So today I want to talk about this problem called minimum operations to make array element zero. So this was one of the problems in like weekly contests recently. I was not able to solve it. Um I spent around 45 minutes to 50 minutes trying to get the idea of what can be done in such a scenario, but I was not able to. But this has a very elegant solution. And it's worth spending some time over. Like, if questions similar to this show up again, then I think I should be able to do it now. Yeah, so let's go over the question. So it says you're given a 2D array queries where queries I is of the form L and R, in both inclusive. Each queries I defines an array of integer nums consisting of elements ranging from L to R, both inclusive, in one operation. You can select two integers A and B from the array. So suppose the query says it's 4 to 9, then basically you have to think of an array which starts from 4 and ends at 9. So 4, 5, 6, 7, 8, 9. That's the array. And from this array, you can take any two elements and then replace them with the floor of A by 4 and floor of B by 4. Now you're supposed to get the minimum number of operations required to reduce all elements of the array to 0 for each query. So let's go through the example that they've given. Queries 1, 2, 2, 4. So for query 1 to 2, it's like there's just two elements. So 1 by 4 is 0. 2 by 4 is 0. You can take both of them because you can select two elements from the array in one operation. So you take both 1 and 2 and divide them by 4 and take its floor value, which will be 0. So this reduces to 0, comma 0 in one operation. Now, next query given is 2 to 4. So the numbers are 2, 3, 4. So in this operation, they're taking nums 0 and nums 2, 2 and 4. When you reduce 2, like replace 2 with 2 by 4, it's 0, and 4 with 4 by 4, it's 1. So the new array is 0, 3, 1. Now you take these two and divide them by 4 again, getting a 0 array. So now for this, you took two operations. So the total number of operations for the entire queries array was 2 plus 1. That's the answer, 3. Yeah, so this is the problem statement. Now let's try to see how we go about this. So the first thing to notice here, one second. So the first thing to notice is if you take numbers 1, 2, let's say I'm just gonna keep writing till I don't have any more space left. So this is the number, okay? So you need to first observe one thing. These three numbers, the first three numbers, will require one operation to reduce them to 0. So 1 by 4 is 0, 2 by 4 is 0, 3 by 4 is 0. But 4 by 4 is 1. So is 5 by 4. 5 by 4 is also 1. 6 by 4 is also 1. 7 by 4 is also 1. Uh, 8 by 4 is 2. So to reduce 4 to 0, you'll need two operations, right? So first you would do 4 by 4. That's one operation, which will give you 1. And then 1 by 4 reduces to 0. So total two operations, right? So this requires two operations. What about 5? Similarly, 5 by 4 will be 1 and then reduce it. 8 by 4 will also be 2 and then 2 by 4, 0. Now take 13 for example. 13 by 4 is 3. 3 by 4 is again 0. So you'll require two operations. So what you'll notice is from 4 to 15, these numbers will require two ops to reduce them to 0. Okay, one op and two ops here. Now you can extend this logic to saying from 16 to 63, which is nothing but 4 power 3 minus 1. till this number, you'll require three operations. So the end of two operations was 4 power 2 minus 1, and the start of the next operation was 4 square till 4 power 3 minus 1. So you see the pattern here. So it starts from 1 to 4 power 1 minus 1 numbers will require one operation. 4 power 1 to 4 power 2 minus 1 will require two operations, and 4 power 2 to 4 power 3 minus 1 will require three, and so on, right? So the number of operations required to make a number 0 when you divide it by 4 continuously is nothing but log of plus 1, right? So if you see, for example, this, if you take 16, 16 is what? Log of 16 with base 4 is what? 2. So you'll require 3. What about 17? 17 will be 2 plus something. So this should be floor of this number. So this is the mathematical formula which tells you how many operations a number requires to reduce it to 0. Now, using this idea, we can, given a range L comma R, we can see, like, find out the number of operations in each of these intervals. Like numbers requiring one operation, number requiring two operations, number requiring three operations. For each of these intervals, we'll see how many numbers are there in that interval, and then find out how many. So suppose, for example, you're given four numbers. Let's say 4, 5, 6, 7. So you know for a fact from our previous observation, this part, that all these numbers require two operations. So this requires two, this requires two, this requires two, this requires two, right? Now, you're supposed to take two numbers together and then reduce them. So I'll take 4 and 5. I'll reduce it to by 4 for both the numbers. So I'll get something like this is 1, this is also 1, this is 6, this is 7, right? And now this requires one operation, this requires 1, 2, 2. Now I'll take 6, 7 and reduce it by 6 by 4 and 7 by 4. So that's 1 and 1 again, right? So now this also requires one operation, this also requires one operation, this also requires one operation. I take these two numbers, reduce them by 4, divided by 4 for both of the numbers. So now the operations required for both these numbers is 0. In the next step, I'll take the last two and reduce them. So we did one operation here. This is plus 1 op, right? Then I did one operation here. Then this is just the number of operations required. So you did one operation here plus 1 op, and then one operation here plus 1 op. So if, for example, you were allowed to take only one element and then reduce it by 4 and not two, how many operations would this range require to make all the elements 0? That's nothing but 2 into number of elements, right? So let's say this was our R, this was our L. So 2 into, which is a number of ops for that range, into R minus L plus 1, right? So this would be 4 into 2, 8 operations, right? So total, it's basically 2 plus 2 plus 2 plus 2 operations if we were only allowed to reduce one number. So that would require 8 operations. But now the question asks we can take two elements together and reduce them at the same time, and that will count as one op. So you see here, it's very easy to get the number of operations required to reduce this to zero. We're just gonna take the this part and divide it by two because we can take two elements together and then reduce them. So the number of ops required for reducing 4, 5, 6, 7 is 8 by 2, which is 4, right? Now, another example. Suppose L ranges were somewhere from here. So this three ops. So let's say it was 16, 17, and 18. So it required three operations for all of them. So how are we gonna go about this? This 3 represents how many operations each number requires, right? So in first operation, we reduce this by something, and now we have 2 ops left, and 3 ops left, right? Now reduce this to 2 and 3 now. So you will have 2, 1, and 2 again. This will reduce to 1, 1, 1, and then 0, 0, 1, and then another operation. Now, just because we don't have any other numbers left which are greater than 0, we'll have to, instead of taking two numbers, we just reduce this and that'll count as another operation. So you'll have 0, 0, 0. So how many operations did this require? 1, 2, 3, 4, and 5. Now, if we try to just use this and do, what will happen? So what if we try this formula, sorry, and try to see how many operations. So there were three elements. Each of them required three operations to reduce to 0. So total number of ops, if we reduce them one by one, would be 9. Now, just because we can take two elements together, it'd be 9 by 2, which is 4, which is wrong, right? Because at the end, we are taking one number individually and trying to reduce it. So what we'll do is we'll add 1 to it and then divide. So 10 by 2, which is 5 ops. So this is the correct answer, right? So now you get the general idea. Now suppose, for example, the range L was 2 and R was 9. So it's 2, 3, 4, 5, 6, 7, 8, 9. Now we know these numbers require two operations to reduce to 0. These numbers require 1. So we can just use the above logic to find out how many operations required in total to make this array 0. So you have 2 into how many elements? 1, 2, 3, 4, 5, 6. 6 elements. 12 ops here, but we can take two of them together and then reduce them. So it will be divided by 2. So 6 ops to reduce all of them to 0. And then for this, it's two elements into one is like number of operations required and divided by 2, that's 1. So you can clearly see. So if you do 2 by 4 once and 3 by 4 once, you're getting 0. So one operation required total for this and 6 ops for this. Totally, you'll require 7 operations, right? So this was the entire logic that I needed to think in the exam with, in the context with, to get to an answer. Now, the implementation of it is pretty simple. So the range is given. So they're saying L and R are between 1 and 10 power 9. So how if we go to 4 power 16, uh, 4 power 17, this number is greater than like our 10 power 9 range. So basically, you would need 16 such intervals, or where 16 operations are required to get to the answer, right? So what we'll do, given a range, suppose one of the ranges lies in this first segment and the other range lies in the fourth segment. What we're gonna do for we'll calculate number of operations required to reduce this to 0 and this to 0. and then whatever is left in this range to 0, and then whatever is left in this range to 0. So this is pretty much it. This is the idea behind this whole question. Now, quickly going over what the solution would look like. So you have like you'll go through each query, and you'll take the start and end point of that query. So in this case, it'll be 1, start would be 1, end would be 2. In this case, start would be 2, end would be 6, right? So what I'm going to do is I'm going to start by saying this D represents how many, like, this is the segment. So D equal to 1 represents the first segment, which requires one operation to reduce the element to 0. So you're gonna go through all the segments and see if this LNR lie, like some of the values in LNR lie in this segment. If they do, you're gonna count the operations by what we discuss to reduce all the elements to 0, and then add the operations of all the elements of all the numbers in all the segments. So going by D equal to 1, so what this would entail is something like so in the first case, if the number is 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12. So in the first case, D would be at this. D is this, right? This previous value is at 1, so it's somewhere over here. Like if you this I equal to 1, it's at this point, and current is 4 into previous. So current is the start of the new segment. So somewhere over here, right? 4. It's on 4. Current is on 4. Previous is on 1. So current will represent the start of the next segment. Previous will be the start of this segment. So now we'll calculate LNR. What are LNR doing? We are checking if any of the numbers in the range this lie in this first segment. So 2 per 6. So we're going to take the max of start. Start was 2 and previous was 1. So start would be here, right? And end would be, in this case, end is at 6. So somewhere over here, right? But we're going to take whatever is in this range. So end will be the minimum of current minus 1. Current was at 4. So current is, this R is here. So now you can check how many elements are there. Totally 2 are there, L minus R minus L plus 1. And number of operations required is D. This is 1. So it will be 2, right? But just because we can take 2 elements in one operation, we're gonna divide it while adding to the end. We're gonna do ops plus 1 divided by 2. Yeah, so this is pretty much it. It wasn't really a tough question, but the idea that you needed to have uh, and like escape me during the contest, and I was not able to do it. But yeah, hopefully in the future something like this turns up. And yeah, so thank you so much.